Swayam Prabha. Digital India. Educated India.
Hello everyone. Now we will discuss on the topic ecosystem services and its risk part 2. In the previous class we have seen that ecosystem services are becoming riskier and are being associated with risks day by day because of the excessive pollution load, mostly man made, in some cases also naturally this is happening. In this class we will try to quantify or analyze these risks. Okay. So, the contents will be risk and hazards, risk analysis, that is hazard identification, risk assessment which includes exposure assessment, dose response and toxicity assessment, risk characterization and risk management and risk communication. Now, we will see what is the risk and hazards. Okay. So, as per the definition of Society for Risk Analysis, hazard is a condition or physical situation with a potential for an undesirable consequence, and hazard can be defined in other way also, that is a biological, chemical or physical agent in or condition of food with the potential to cause an adverse health effect. And risk is the probability of an adverse outcome. It is a situation involving exposure to danger, and risk is a function of hazard and exposure. Hazard means how bad the substance is, and exposure how much have we taken in. So, these two factors influences or decides the actual risk. One is hazard and other is the exposure. So, we see that hazard is something with the potential to cause harm, and the risk the likelihood of occurrence and the magnitude of consequences of a specified hazard being realized. So, this is the risk and hazard by definition. Now, we will see hazard categories and examples of potential hazard manifestations. So, hazards may be related with human, may be related with environmental toxicity, it may be with say it may be of physical hazards, it may be global hazards. So, for example, say human toxicity hazards, carcinogenicity, neurotoxicity, hepatotoxicity, nephrotoxicity, cardiotoxicity, hematological toxicity, endocrine toxicity, immunotoxicity, reproductive toxicity, teratogenicity, mutagenicity, dermal toxicity, ocular toxicity, enzyme interactions, and environmental toxicity hazards may be aquatic toxicity, avian toxicity, amphibian toxicity, phytotoxicity and mammalian toxicity, that is non-human. And physical hazards we have already discussed in the introduction class, that explosivity, corrosivity, oxidation or combustibility, okay, the reducers, pH and violent reactions with water. So, those are the physical hazards, and some global hazards, some new hazards have been identified with respect to climate change. So, those are say global warming, okay, ozone depletion, acid rain, security threat, water scarcity, flooding, persistence and bioaccumulation, loss of biodiversity. So, these are the different types of hazards have been classified or categorized into these. Now, we will see how we will do the risk analysis. So, analytical process, it is an analytical process to provide information regarding undesirable events and process of estimating probabilities and expected consequences for identified risks, and detailed examination including risk assessment, risk evaluation and its management, which is performed to understand the nature of unwanted outcome. And we will see the objective of risk analysis and the steps. The main objective of the risk analysis is to balance risks and benefits. Certainly, you know, when we are taking up new initiatives, we will be getting some benefits and there will be some risk also. So, we have to consider both and take an optimum situation, so that balance risks and benefits, that is the main objective to the risk analysis, and then set target levels of risk and then set priorities for program activities. So, that means that I told you that if I want to take new initiatives, I have to optimize it, so that the environmental impact will be under control. So, that way the risk analysis is necessary. And then post remediation to reduce risk, again what remediation measures we can take to eliminate these risks, that also the objective of the risk analysis. And how we can do it? So, first job is to identify the hazards or what are the risks basically. So, hazard identification and then risk assessment, we have to assess the risk from the hazards, and then we have to risk management and risk communication. So, now one by one we will see how this can be taking place. Hazard identification. So, you know, the identification of the hazard, that is something potentially harmful, that is hazard in the given context, this can be directly included in risk assessment. So, we will be examining the hazards. For example, say there is some accident in the industry. So, there will be some chance of release of some poisonous gases. Okay. So, that is one hazards I am identifying, or say we are getting some smell in our room, then just like a melting of plastic. So, we will be taking care to find out where from it is coming. Okay. So, what is the source of it? So, that is the identifications. Then the first we will identify the hazards, what is the hazards. Okay. So, that hazard identification, and then those points or those information will be used for the risk assessment, and risk assessment is the process of evaluating the risk resulting from a hazard, any sort of hazard, what will be the risk of it, that will be assessing. And then risk management, the based on the results of the risk assessment and the judgment of the risk managers, those experienced persons who have knowledge on this subject, they will be assessing it and they will take a decision, okay, are taken, and then the policy is formulated, and then the policy will be formulated. And risk management is the process of weighing policy alternatives in consultation with all interested parties, considering risk assessment and other factors. So, you know, we can correlate with this with the formation of the standards of different pollutants in our environment. When it say some waste stream is entering into the environment, then what will be the limit of different contaminants in it. So, that particular value we need to decide. So, that will be based on our risk factors, and in that case we need to involve all stakeholders, then decision is taken. The decision is also open, well, before taking a final decision, that interim decision is opened for public comment, and then it is finally accepted as a rule or regulation. So, that way risk management and risk assessment and risk communication is also very important. So, risk communication is information exchange between risk assessors, risk managers, and those affected by both the risk and the decisions taken before the final policy decisions are taken. So, these are the process through which the risk analysis takes place. Now, this slide shows us the different steps which we have discussed the same in this diagram. So, hazard identification, then we will do the risk assessment, which is composed of say exposure assessment, then dose response assessment, and then risk characterization, and then we will do risk communication and risk management, both take place simultaneously. Okay. And risk assessment is basically exposure assessment, dose response assessment, and risk characterization. Now, we will see what are these. So, hazard identification. So, what is this? To identify chemicals of concern, which chemicals is responsible for that. For example, say we see that sometime on a river Yamuna the fishes are floating, dead fishes bodies are floating on the water. So, what is the reason of it? We have to identify. Say we have got a news that such and such village there are many people are affecting from cancers. So, what is the reason for it? So, we have to identify that hazard identifications. So, what is the agent and what are the effect? So, that first job, and that can be done by field work and studying the scientific aspect of this phenomena. Okay. To collect data on concentrations and location, and then to collect data on factors affecting fate and transport. So, all those things are necessary. So, that way we can identify the hazards. So, example says some concerns are there in the village. So, the groundwater is contaminated with heavy metals, with arsenic or fluoride or many things. So, we have to analyze all those water for the presence of these contaminants. So, that way we will do it, and then we will do the exposure assessment. So, how we can do that exposure assessment? Now, we have identified what are the hazards, what are the chemicals present in it. Then we will decide what is the duration the people is exposed to it, or what is the agent found, then what are the routes of exposure and how many people are exposed. Okay. So, who is exposed, what is the intensity, frequency and duration of exposure. So, all those things we will be considering, and we will collect data on these for exposure assessment. Then we will define exposure. What is that? Intensity into frequency into duration. What is the intensity, what is the frequency and what in the duration? That means how much, what is the concentration of the chemicals, how often I am in contact with, and how long I am considering that. Say I am living in a particular region for last 30 years. Okay. So, during last 30 years what is the exposure. So, that is, and every day say I go to that particular area for 2 hours a day. So, 365 into 2 hours per year. So, that way how often and how long. So, that is into consideration, and how much, what is the concentration present in that. So, that will be considered to get the to characterize or to quantify the exposure, So, characterization of the exposure setting, then identification of the exposure pathway and quantification of the exposure. So, these are the main steps for exposure assessment. Then here how we will quantify the intake rate per mass of human body, how much pollutants we are taking, intake rate. So, that is I, generic term is I, intake, that is equal to mg per kg per day. So, per day how much mg of pollutants I am taking per 1 kg of the body mass. So, that is called intake rate. This is chronic daily intake. Chronic daily intake means that is very small concentration we will be taking this. Okay. And there are two types of effects basically, one is chronic effect, another is your acute effect. So, acute effect, the concentration of the pollutants will be more and immediate impact we will get, but for chronic effect the concentration of the pollutant will be less, but for long term consumptions we will be getting the impact of it. So, that is called chronic daily intake, that is intake mg per kg per day, where I is equal to Ce into Ri into Ef into Ed divided by Bw into At. So, Ce is equal to exposure concentration, that is mg per liter, what is the concentration of the pollutants, and then Ri is the intake rate, that is how much water, if we take say how much liter of water I am taking per day, and then Ef is the exposure frequency, how many days in a year I am living in that area, and Ed is the exposure duration, how many years I am there, and Bw is the body mass, what is the body mass of myself or the living organism or the human, and then 8 is the averaging time. So, that is very important, averaging time, that is the period over which exposure is averaged in days. So, these are the terms which are used to calculate the intake rate for a longer period or chronic intake. Then EPA, Environmental Protection Agency USA, so they have some default values for the use in exposure assessment calculations and for residents and workers. RI, that will be rate of intake, that is 2 liter per day for drinking water, 100 mg per day soil and dust ingestion, and 30 meter cube per day air inhalation. And for similarly EF, which is exposure frequency, that is 350 days per year, and for resident ED value is actual event duration or 30 years if chronic. If we want to consider for chronic intake, so then that will be 30 years, but for actual event, that means for your acute intake. And BW is 70 kg for adult and 50 kg for child, and AT is the actual event duration if not carcinogenic, or 365 days per year into 70 years. Now, we are going to see what is the dose response and what is the toxicity assessment. Okay. So, dose and response, how is the identified adverse effect influenced by the level of exposure or dose, that is the concern. So, you know, if we take more dose, more impact we will get, you will get less dose or less concentration, there will be less chance of contamination. So, that way dose response assessment is needed, and for that what we do, this can be done using different animals. So, animal studies, that is specialized toxicity studies, generalized toxicity studies and in vitro studies are done, and then for human studies we case reports, then cluster analysis, epidemiological studies, just like say vaccine productions for COVID-19. Initially it was tested from animals, then when it got success, then selective people are identified, and then that was administered on that group of, and then case reports and cluster analysis like this. So, that way the toxicity is assessed or the dose response, what will be the dose, that is determined. Okay. Now, why the animal studies is considered before administering the drug or the toxic element into the human body? Because you know there is good correlation with human disease, human carcinogens cause cancers in animals as well, and acute toxic doses are similar in humans and a variety of animals, and anatomical, physiological and biochemical patterns are similar among animals accepted by the scientific community. So, that is why the animal studies are taken first. When we do this toxicity assessment test, so normally we try to understand the impact of the risk on respiratory system, blood and limb, liver, kidney, nervous system, skin, reproductive toxicity and teratogenicity. So, these are the different endpoints basically or target which we want to know the impacts on these. Now, dose response curve are also there, graphs are also there. So, here you see the first one, it is a straight line, that is linear dose response curve, but this is not a straight line, it is dose response curve, this is not linear one, non-linear we can say. So, here this curve is basically applicable for carcinogenicity, the cases where the material is carcinogenic in nature. And here this del y by del x, if this is del y and this is x. So, probability of contracting cancer, that is risk, and x is your dose. So, the del y by del x is giving up slope factor. So, this slope factor value determines the risk actually, more the slope factor value, more is the risk. Okay. So, it will shift it that way more risk and it will shift it this way less risk. Okay. Similarly, when we think about the systematic toxicity, that means in this case the impact is not carcinogenic in nature, and as per EPA some reference dose is considered, as per EPA some reference dose is considered. So, in case of systematic toxicity where the risk is not carcinogenic in nature. In that case reference dose is considered as per EPA, and then one NOAEL is considered, no observable adverse effect level dose, this level, and up to this we see there is no the probability of adverse health impact is very less, 0. So, at RFD normally it is 0. So, below the RFD value there will be no risk basically mostly, and this RFD will be lower than NOAEL sometimes, okay, it may be say 10 times lower than that, and there is some threshold value like this. So, this way this is for non carcinogenic effects, these are the dose response study, and this is dose response for carcinogenic elements. Now, the RFD, the reference dose, is useful as a reference point from which to gauge the potential effects of the chemical at other doses. Usually doses less than the RFD are not likely to be associated with adverse health risks and are therefore less likely to be a regulatory concern. So, RFD is a benchmark dose operationally derived from the NOAEL by consistent application of generally order of magnitude uncertainty factors that reflect various types of data sets used to estimate RFD. So, the relationship RFD is equal to NOAEL divided by UF into MF. So, MF is a modifying factor, somewhere you may get this relationship RFD equal to NOAEL by UF, and somewhere you may get this relationship as mentioned here. So, that MF is a modifying factor is sometimes used which is based on a professional judgment of the entire database of the chemical which is used. And then for non carcinogens, you know, the risk is determined as the hazard quotient. So, one is hazard quotient, another is hazard index. So, what is hazard quotient? Hazard quotient is I non carcinogenic divided by RFD. What is this I non carcinogenic? It is intake. So, intake divided by RFD. Okay. The RFD is the ratio of the no observable adverse effect level over the uncertainty factor. So, that we have already discussed, and when several substances are present, not only one substance, more substances are present, then simultaneously we will be taking the hazard index for that case. So, hazard index is equal to sum of HQ, that is the sum of the hazard quotient. So, now HI and HQ are dimensionless, and the RFD values that go in the denominator in these expressions, okay, are such that the critical value of HQ or HI is 1. So, more than HI means it is unsafe. So, that will be not be safe, and there will be some risk with that under that conditions. And uncertainty factors which we have seen UF, that is basically 10 for human variability, 10 for extrapolation from animals to humans, and 10 for dose of less than chronic data. That means 10 times, that is RFD will be 10 times less than the NOAEL. Then for carcinogens the slope factor is measured, and for non carcinogens the reference dose is measured. We will be below that RFD dose, it is safe. Now, these are some example for arsenic, benzene, benzopyrene, cadmium, chloroform, chromium 6, 1 on dichloroethylene. So, you see oral RFD, that means when we will take orally these pollutants, then RFD is this mg per kg per day, and when SF will be this, and when we will take inhalation through the inhalation from the air. So, the SF value are given here. So, the values are different, and for other like say methyl mercury, naphthalene, PCBs, dioxin, toluene and vinyl chloride, the other values are given here. Now, another is your lethal dose. So, when we want to quantify the dose response on the dose with acute impact, at that time we get lethal dose. So, lethal dose is an indication of the lethal toxicity of a given substance, and it represents a dose usually recorded as dose per kilogram of subject body weight, at which a given percentage of subjects will die. For example, say LD 1, LD 50, LD 99, LD 50 means 50% of the subjects will be dead at that dose if it is exposed for certain time. Okay. Similarly, LD 1 means 1% will die, 99 means LD 99 means 99% of the subjects will be dead. So, the median lethal dose L 50 abbreviation for lethal dose 50% of a toxin is the dose required to kill half the members of a tested population after a specified test duration. And LD 50 figures are frequently used as a general indicator of a substance's acute toxicity, and a lower LD 50 is indicative of increased toxicity, and the LD may be based on the standard person's concept. A theoretical individual that has perfectly normal characteristics that is used and thus not be applicable to all subpopulation. That means, this is for a perfectly normal adult persons can be considered for this investigation, not a children or etcetera. And risk characterization report, next is your risk characterization. So, after assessment we will be characterizing it, that means we will be maintaining a report, we will preparing a report basically from the start of it. So, describe risk assessors, risk manager planning and results, and then reviews and discusses major data sources and analytical procedures used, just like a report writing, okay, and reviews stressor response and exposure profiles, that will give data, the what type of trend we are getting, and then summarize a risk to the assessment endpoints including risk estimates and adversity evaluations, and reviews and summarizes major areas of uncertainty and approaches to address them. So, this is the risk characterization, then risk management and risk communication. So, what risk characterization is made on the basis of decision is taken and that decision is communicated. So, that risk communication is defined as an interactive process of exchange of information and opinion between risk assessors, risk managers and other interested parties. Risk communication is an integral component of risk analysis, and we also see that risk communication assists in overall understanding and approval of risk management decisions. Okay. So, this is the total flow diagram we see. So, planning, problem formulation, analysis, risk characterization. So, risk estimation, risk descriptions and risk communication and then risk management. So, for this we need acquire data, iterate processes and monitor results. So, these are the process for risk management. Okay. So, up to this in this class, thank you very much for your patience.